Okay, so now I'm gonna start solving this problem. This is a pretty classic one on Leetcode. I don't know why I have never solved it. It doesn't show that I solved it before. Um, so my idea is like, so I need to find the middle of linked list, and my idea is like to have like fast pointer and a slow pointer, and slow pointer gonna go one node at a time, and a fast pointer gonna go two nodes at a time. And as soon as the fast pointer gonna point to the end of the list, the slow pointer gonna point to the middle. The only issue in this solution is that I need to be careful here to figure out. So in case there are two middle nodes, return the second middle node. So I need to account for this, and also like account for like whenever I have like three nodes, the one I should be pointing into like as a return that should be like the middle one. So let's assume I have, let's have this simple example. I have this 1, 2, 3, and then let's say the end of list. Let's say I have a pointer, the slow and fast pointer, slow, fast, and then I move move fast pointer two nodes at a time, and move slow pointer one node at a time. So move slow one node and move fast two nodes. And then now I see that the fast pointer like points to the last element because like next one is none. So the slow pointer must be pointing on a middle one. So let's assume we have four nodes. In this case, I need to point to this node 3 as a middle one, because it should be the second middle one. So I move fast and slow pointer. So I move fast two nodes at a time, slow one node at a time, slow fast, and then fast one and then two. Okay, so moved it here fast, and then the next one is none, so I don't move it, and then I move slow with one node at a time. Okay, so let's say we have 6 elements. I want to just practice on a bigger 1, 2, 3, 4, 5, 6 again. Let's move, see how it's gonna work. So fast, slow, move fast, 1, 2, move slow 1, slow fast, then again move fast, 1, 2, fast, then slow gonna be here, and then we have again the same pattern here. Like fast, I try to move 2 steps, but I cannot, I just move 1. So I move until I see the end. So fast, until I move fast pointer until there is a node that points to the last element, and then I move slow pointer. In this case, fast points to the last, slow points to the middle. So there are two middle nodes. And according to the task, I should return the second or last middle. So I need to return 4. So I'll start coding. Again, that can be number of nodes in the list is in range 1 to 100. So in case of I have one node, should I return 1? In case like let's check like the simplest case. So in case I have like 2 nodes, 1 and 2. So I'm gonna move fast point gonna point here, and then I'm gonna move slow gonna point here also, and I need to return the second one. Okay, so 2 nodes work, 1 node didn't work, so I cannot move the fast and slow, they stay the same, and then I return whatever it's pointing to. and there won't be they will be actually none element. So if head is none, I'm gonna return none. And then in case I'm gonna have fast pointer, fast equals head, and then slow equals head, and then I'm gonna go while fast dot next not equal is not none. I'll do fast equals fast dot next if fast dot next not equal none. Let's check again. If not none, I'm gonna go fast again equals fast dot next, and the next one gonna as slow gonna be as dot next, and then in the end I'm gonna return just as slow. It should work. Let's check it out if it works. Return none. Okay. Yeah, so that's it. I'm thinking right now how I can I can actually like have the solution where I can have like fast point or like just a pointer that can go through the list and then figure out what's gonna be the length of the list, and then I can have another pointer that's gonna be like move half of the elements and then return it. But and in that case, so like in this case I'm like, so fast pointer, so the number of operations actually gonna be the same. It's this one is just a little bit smarter way to do that, but yeah, like having that pointer going, let's say I have like ptr equals head, and then while ptr next is not none, I wanna do so size equals 1, size plus equal 1, and then ptr equals ptr next, and then here I'm gonna have if head is none, I'm gonna return none, and then here I'm gonna go middle equals size over 2, and then car equals, let's say 1, while car less than middle, I'm just gonna do car plus equal 1, and then ptr equals head, and then ptr equals ptr next, and then I wanna return ptr. No, output current less than middle, size over 2. So let's check what's the size here. Print file size 5, correct. So it should be, so current gonna be 1. So let's say current 0. Yeah, it's a little bit minor mistake. I forgot that I start from 1. So if I wanna do this, current equal 1, and then so middle should be this one divided by 2 plus size mod 2, I guess. 2. No. So in this case I have like an even number. So in this case size over 2, so size should be print size. Gonna be the size here. Size gonna be 6, so correct. So 6 over 2 gonna be 3. So I should be size over 2, and then here 1. So in case I divide it over 2, it should be in case if it should be 3, and it should be 4. So in case it's divided by 2, it should be something like this. And then in case of it's 1, or like size over 2 plus. So like let's say we have 3, and I divide it by 2. So it should be always be 1. Just like that. Yeah, but again, like in order to skip that one, I'll just do that over 2 current 0. This one gonna be much more easier. And then in this case 6, I need to 6 over 2 gonna be 3. So exactly what I need. And then yeah. Yeah, so hope it was not too confusing. All this math, like mod and then like conversions from like 0 base to 1 base and then back and forth. But yeah, that's gonna be it.